Title 150th Anniversary of Meteorological Services, Considerations on Global Warming 3-1, A Study on Energy Consumption, author at CES 6919. Abstract in Reference 1, the annual average temperatures from 1875 to 2024, as recorded by the Japan Meteorological Agency, were mainly examined. This time, monthly average temperatures are addressed. Introduction: the method used in Reference 1 is applied to monthly average temperatures. However, according to Reference 2, primary energy supply data is only available from 1953, so the period considered is 1953 to 2024. The focus is on verifying the disadvantages of global warming: 1. Frequent extreme weather events, 2. Impact on agriculture, 3. Impact on health, and 4. Sea level rise. However, during editing, a new insight was found regarding primary energy supply, so this is summarized as 3-1. Additionally, findings from Consideration of Global Warming 688-1 are also included. Method: the method identified in Reference 1 is expressed by the following equations. Details are omitted here. See Considerations on Global Warming 2 for more information. Formula 1, S times open parenthesis 1 minus a close parenthesis times pi r e squared minus a equals 4 pi r e squared sigma t e to the fourth. S, solar constant 1.37 times 10 superscript 3, W/m superscript 2, 8th albedo, RE, Earth's radius, km, sigma, Stefan Boltzmann constant 5.671 times 10, W/m superscript 2k, Te, Earth's surface temperature, A, energy diffusely reflected by Earth's surface. Formula 2, sigma T e to the fourth equals sigma T prime e to the fourth plus the sum from n equals 1 to infinity of e sub n. Formula 3, 0.9s1 plus sigma tg to the fourth minus open parenthesis sigma t prime e to the fourth plus the sum from n equals 1 to infinity of e sub n close parenthesis equals 0. Formula 4, 0.1s1 minus 2.0 sigma tg to the fourth plus open parenthesis sigma t prime e to the fourth plus the sum from n equals 1 to infinity of e sub n close parenthesis equals 0. In these equations, S, solar constant, S1, radiation from S, 8, albedo, RE, Earth's radius, sigma, Stefan Boltzmann constant, T, Earth's surface temperature, A, energy diffusely reflected by Earth's surface, T, observed temperature, T, temperature excluding E, Tg, stratospheric temperature, E1, primary energy supply, E2, energy from nature, E3, energy input from other regions of Earth, E4, energy input from other celestial bodies, etc. The origin of the cycles in Reference 1 is unclear, hence marked as unknown. Method, continued, here, it is assumed that T is almost equal to T. Since the primary supply energy from the Agency for Natural Resources and Energy is known, substituting E1 allows the influence of E2, E3, E4, etc., to be highlighted. The primary supply energy data is annual, so it needs to be adjusted to monthly values. This was done by calculating daily supply from TEPCO's 2023 supply results, Reference 3, and deriving monthly coefficients, shown in Table 1 and Figure 1. Method, continued, Table 2, assuming that other primary supply energies follow the same trend as electricity, calculations were performed and shown in Table 2, only January is displayed due to space constraints. The columns for judgment A and B are explained later. The corrected albedo A1 is the albedo calculated excluding primary supply energy. The value of E1 multiplied by the previously obtained monthly coefficient is denoted as E1 foot. Next, the relationships among A, T, and E1 foot are shown in 2D graphs, figures 2, 1 and 2, 2 and 2, 3, 2 to 4, with only January as an example. Red indicates the maximum value, blue the minimum. Then, by expressing the approximations of figures 2, 1 and 2, 2, and 2 to 3 in Cartesian coordinates, the appropriate ranges are determined and shown in figure 2, 5. Method, continued, figures 2, 1, 2 to 2. January T, a relationship diagram. January T, E1 foot relationship diagram. Method, continued, figures 2, 3, 2 to 4. January E1 foot, a relationship diagram. January T minus T, E1 relationship diagram. Method, continued, figure 2, 5. 3D graph showing the relationships between T, A, and E1 foot. Results. Table and graphs showing the results when visualized in 3D, it becomes figure 3, 1. Considering the monthly transitions, it appears as figure 3, 2. It is easier to see if January is placed after December, starting from February, so that January and February do not overlap. This seems to clarify the meaning of the old calendar. Explanation of Judgment A and B columns. Judgment A, if the value calculated using Formula 7 is less than E1 foot, it is marked times, if equal to or greater. In figure 3, 1, the range exceeding the green area is times. Judgment B, if the value calculated using the minimum for the month is less than E1 foot, it is times, if equal to or greater. In figure 3, 2, the yellow area represents this. In figure 3, 2, the maximum allowable primary supply energy for the month is connected to that of the following month, so there are slight differences. Formula 5, 6, 7, 8, Table 3. Results, continued, figure 3, 1. 3D visualization of the results. Results, continued, figure 3, 2. 3D visualization considering monthly transitions. Discussion, figure 4, 1. First, from the results table, it is noted that the R superscript 2 value is extremely low compared to the case of annual average temperature, and there is monthly variation, as shown in figure 4, 1. Although not discussed in detail here, the relationship between sea surface temperature and air temperature is shown in figure 4, 2. Discussion continued. Figure 4.2. From figures 4.1 and 4-2, it is clear that the function that makes our superscript 2 equals 1 by addition is the sum of e2 foot, e3, e4, etc., as expressed in formula 2-4 for n equals 2 to infinity. The red curve closely resembles plant activity. In January, it is cold, broadleaf trees shed their leaves, and conifers are less active. From February to June, as temperatures rise, conifers enter their breeding season and shift to high metabolic production, while broadleaf trees sprout new leaves. From July to September, solar radiation is high and activity peaks. In October, broadleaf trees lose their leaves and activity decreases. October is also the breeding season for seaweed, but activity decreases, while from November to December, sea surface temperature is higher than air temperature, possibly increasing activity. Judgment A and B are illustrated in 2D diagrams, figures 5.1 to 5-12. Discussion continued, figures 5.1, 5-2. Monthly trends of primary supply energy, Judgment A, and Judgment B for each month, January to December. To explain in detail here, the x-axis represents the year, and the y-axis represents E1 foot, watts per square meter. The blue curve shows the year-by-year trend of primary energy supply. The orange marker is E1 foot, which was obtained by substituting the albedo of the year by Formula 7, and the orange dashed line is a linear approximation of it, and the formula represents it. This was used in Judgment A. Finally, there is a straight green line, which was calculated by substituting the lowest albedo number between 1953 and 2024 for that month by the Formula 7, and was used for Judgment B. Discussion continued, figures 5.3, 5-4. Discussion continued, figures 5.5, 5-6. Discussion continued, figures 5.7, 5-8. Discussion continued, figures 5.9, 5-10. Discussion continued, figures 5.11, 5-12. Discussion continued, figure 6. Finally, figure 5-112 is shown in figure 6 with the front and the side figure in figure 6. As shown in figure 6, first of all, the line of judgment B located at the top is calculated by the lowest albedo number for each month between 1953-2024, and the maximum allowable E1 foot is. Returning to figure 5-112, it can be seen that there was a period of time exceeding this except for January, March, October, and November. This is the second solid blue line from the top, which is the result for 2022. The third green dashed line is a linear approximation of the orange marker in figure 5-112, and the tolerance at the time of 2022 as E1 footed is a representative. Comparing the solid blue line and the dashed green line, the solid blue line is slightly higher than in February, March, June, July, August, September, and December, but it is estimated to be below this as of 2024. In addition, the orange dashed line is the Judgment A line as of 1953, and the solid purple line is the Judgment A line as of 1900. According to his book Global Warming Considerations 6A8, the 2022 Judgment A line will continue until 2074, but in 2180 it will drop to the solid purple line. The extent to which this purple line is the blue line is calculated by integrating the approximation formula is about 71%. We have experienced this, and it is at the level of 1970. Considering that nuclear power plants were started in 1966, it is necessary to reconsider whether nuclear power plants are necessary in Japan, where tectonic movements are intense. Conclusion. The approximation formula announced by the Tokyo Meteorological Agency, which approximates the annual average temperature obtained by averaging the average monthly temperature from 1876-2024 with a sine wave 2 term, is considered essential for the realization of a sustainable society. I examined the period 1953-2022 of the primary supply energy with my own eyes, and focused on the linear movement of the Judgment A line, and estimated the year 1900, which was truly shocking. This is about 71% of the current energy content. As I wrote in the discussion, the 2022 Judgment A line will continue until 2074, but after that, it will descend to the purple Judgment A line until 2180. By 2074, about 50 years later, measures must be considered and implemented. Future prospects. This time, I summarized it as 3-1, so I will summarize what was mentioned in the introduction separately. References. Reference 1, author's own work, Consideration of Global Warming 6.8, URL, www.youtube.com/@kazzy6919. Reference 2, Agency for Natural Resources and Energy, Comprehensive Energy Statistics 1990 to 2022, Trends in Domestic Primary Energy Supply 1965 to 1989, Comprehensive Energy Statistics 1953 to 1964, URL, omitted, search November 15, 2024, URL, omitted, search November 15, 2024, URL, omitted, search November 15, 2024. Reference 3, TEPCO Holdings, Tokyo Electric Power in Figures, Monthly Peak Power Demand, URL, omitted, search November 15, 2024. The end.